We'll proceed in various coordinate system, and we had calculated surface area through interoperability. Now we will proceed in calculating the volume, and we'll see different aspects of calculus integration. Calculus, you are amazing, you are different, you are amazing, you are marvelous. But calculus, sometime if you have something, it does not shine. If you have another thing, it does not shine. If you have another thing, three different things in its own shape, that in its own form, they do not shine. But if you mix them together, use them together, then they start shining. Probably calculus means addition, algebra, vector, they do not shine. Or if I add one more thing, that is coordinate system, they do not shine, or they do not shine to the extent. But if you group them together and you understand how to use them in a kind of a group fashion, then it starts shine. So that is the concept. So here we have seen vector, algebra, coordinate system, calculus, how we can use it together. Interoperability means one using other and here and there. And so quickly, so nicely, we calculated the surface area of a sphere. Surface area of a sphere. What about calculating a volume? Volume of a sphere? Okay, so calculating surface of a sphere was not very easy. What we saw while calculating the surface of the sphere, what we saw calculating the surface area of the sphere, that whatever the algebraic equation we had, and then we did integration of that through dA, area, integration of that through the area. If we do so, calculating the integration through the area, then later we saw, even though we begin with the Cartesian coordinate system, but if I have a sphere, okay, I really have a sphere. I have a sphere, okay, or I have a sphere. Then if you see this sphere, okay, so this is north pole of the sphere and this is south pole of the sphere. Now if I keep this sphere centric on the origin, then if I cut this sphere, or if I tilt this sphere like this, and then if I cut it at the center, then the xy plane is the xy plane contains the origin of this sphere, and xy plane anyway, it has the origin. So center of this sphere and origin both coincide, they are at same point. If xy plane is there, then the dA, the area what we calculated, so if while calculating the surface area, we started with the velocity vector. So we started with position vector, then we calculated the velocity vector. Please refer last video. And if I have velocity vector, then I have velocity vector along x-axis and y-axis. If I do cross product, then I get the area velocity vector. If I get area velocity vector, then I get the magnitude. If I get the magnitude, if I integrate that magnitude along the xy plane, I get the net area. Net area in terms of algebraic equation, that if we keep changing independent variable of algebraic equation x and y, we start getting area from the beginning. So if this is the sphere, and this is the beginning. Then from here I start getting the full area as we change the x and y in the area calculation. So in x and y in area calculation, if I change, uh, if I have done the area calculation, the net result would be in algebraic equation. If I keep increasing x and y from 0, so if I say 0 comma 0, 0 comma 0, then it would result 0 comma 0 would result in the area at the beginning, that is 0. If I keep increasing, then area would increase. This is what we keep the limit. Like if I follow polar coordinate system, then I believe that we had something or a spherical coordinate system. The second hybridization we did. I think our way is more logical somehow. I would say more easy. Then I remember that it came to sine phi d phi, sine phi d theta d phi, sine phi d theta d phi a square. So a square is the radius of the sphere. A square I keep outside. Then sine, then d theta sine phi d phi. So d theta, if I calculate, then it comes as theta. Integration d theta is theta. Leave it as theta only. And then if I calculate now the sine phi d phi, then integration would result in minus cos phi. So net integration is minus theta a square minus theta cos of minus a square theta cos phi. If that is the net integration of 4, now I have to set limit where theta is 0 to 2 pi and phi is 0 to pi by 2. If that is the case, then it would result in 2 pi a square, because 0 to 2 pi would result in 2 pi, whereas cos phi 0 to pi by 2. So pi by 2 cos phi is 0, and then 0 is 1, that is minus, so minus would go away. So now what is the integration if we see, that is theta cos phi. Now if I have the surface area, then the net integration we received as a algebraic equation only, that is minus a square theta cos phi. Now if I change the theta and cos phi accordingly, I can see the surface area. If theta is 0, then surface area is 0. So we calculated the surface area, and this is the theta in the xy plane, and this is the phi. We call it something like, this is z, this is phi, and this is the radius. So the surface area is in algebraic equation of theta and phi. If theta is 0, means it is at the beginning, so surface area is 0. If phi, net result comes as cos phi. So phi is 90 degree and theta is 0, then it is certainly 0. If theta is some value and phi is still 90 degree, then full phi it is 0, or theta is 0, then it is 0. So in xy plane the surface area is 0. If this angle is phi, then phi is 90 degree, then cos 90 is 0. So full, because there is just a line, it's not a surface area. So phi has to be some angle and theta has to be some angle. Okay, where phi is not 90 degree, then it starts calculating the area. Where is the beginning? Beginning is theta equal to 0 and phi equal to 90. So this is xy plane of the sphere, and then this is the beginning. Theta is 0 and then phi is 90 degree. Now if I start increasing the theta and this direction, so this way it will start calculating the area. So integration is nothing but integration of algebraic function, but at the end it would result algebraic function as result also. That result is nothing but net collection, net area. that you have to change the independent variable, or I would rather say start from 0 and keep increasing it. So from beginning, you will start getting the net collection. So that is integration. Now let's calculate the kind of surf volume. So if I have a cube, then what is its volume? So there are two ways that we can calculate. One is through, if I take any infinitesimal small distance, small cube, okay, that is typically you will find in any of the book. So if there is a small cube, there is a big cube, length is a, length is a, this is origin. So length is minus a 2 plus a, or minus a by 2 to plus a by 2. So one side of the cube is a. This is y-axis, minus a by 2 to a by 2. This is z-axis, and minus a by 2 to a by 2. Now if this is a cube, inside the cube there is an infinitesimal small cube I have taken, that width, length and height is delta x, delta y, delta z. So what is the volume of the cube is delta x into delta y into delta z. Now if I grow it for full cube, then that will be, and delta x, delta y, delta z is tends to 0, infinitesimally small, then it will become dx, dy, dz. Now integration, triple integration, dx, dy, dz and triple integration. So that is one constant. So now it will come as x into y into z is the integration. I will try another way. What is the volume of a cube? What is the volume of a cube? If height is kind of a by 2, height is a by 2. Okay, that is the equation of the z, fxy equal to a by 2. Fxy equal to a by 2. Now we are talking about half of the cube. So there is xy plane. In the xy plane, if I take any xy, then for that resulting value is a by 2. So if that is the case, then from minus a by 2 x is there, and then minus a by 2 to a by 2 y is there, and for any x comma y, the height is fxy is a by 2. That is the equation. Then if we calculate the area, area, area through integration we calculate the area. Okay, area means what is the next step. So if I have independent variable at xy plane, and if I calculate the integration, then certainly it will calculate the volume one step higher. So if I say that d, whatever the algebraic equation is fxy, this is not available in any of the book. This is actual calculus, fxy dA, where independent component is xy plane. If xy plane is independent component and height is fxy, then fxy is the algebraic equation of the surface. Then fxy dA, area of the plane, fxy dA. Now area of the plane dA, I have to start from the one corner of the area to another corner of the area. Now if I say dA, that is calculation of area in x-axis and y-axis, there are two independent components. They are related in a fashion that area of any rectangle is width into height, then dA would be converted to dx dy. Dx dy. Fxy would convert it to a by 2. Now integration of a by 2 dx dy. Now this one single integration converted to two integration. One is minus a by 2, another is minus a by 2 to a by 2. Outside into 2, because first half I am calculating multiplied by 2. This is actual calculus that is not available in any of the book. You have to find the equation of the surface for which you are trying to calculate the area. Means if I see two-dimensional, then there is a x-axis, and on top of x-axis there is a function over x-axis. If there is x-axis, then there is a function over x-axis. If I want the area of the function from one point in x-axis to another point in x-axis, then I have to calculate the integration. This is what we have seen. If I have to calculate the integration, then I get the area. If this fx, if I change this fx to fxy, then this is equation of a surface. And this x-axis, if I change to xy plane, then if I calculate this integration, it will calculate the volume. This is what we want. This is we will place disclosure for it also. Okay, we are in phase of filing disclosure 500 to 1000 to 2000. 1000 to 2000. So one we have placed at medium.com/@ meaning. So there we have already placed one that can be seen. Medium.com/@ meaning. MINHINC, that is the channel name, or meaning.medium.com, unsupervised learning. Anyway, now if I want to calculate the volume, then I have f function xy dxy plane. Dxy plane can be changed to dx dy. If it can be changed to dx dy, then integration, the single integration, that is the surface xy plane integration limit, would change to x and y separately, minus a by 2 to a by 2, minus a by 2 to a by 2. Now a by 2 is the function equation. If I, this is a knowingly unknowingly a constant. If I could keep a by 2 outside dx dy, then first dx integration is x, a by 2 minus a by 2 a by 2, that would result in a. Dy is again integration is y minus a by 2 a by 2, again a. So a to the power 3 by 2 is the volume of the cube. If that is the case, then the net volume of the Q is a to the power 3. Why this is better in a sense that this gives in a density function calculation. Density function calculation where I have a volume, I have a cube, and cube is made up of iron. Cube is made up of iron, and there is a origin point of the cube. But density of the iron, kg per meter cube, the density of the iron changes as per the xyz. It has some function. Everywhere the density of this iron is not same. Somewhere it is high density is there, somewhere less hollow is there, less density is there. This is way this is the cube is made. That is fxyz, function over xyz, that is called density function. Then we have to calculate now what is a density function is nothing but kg per meter cube. If I have density function that is not constant, then what is the weight of this cube? Weight of the cube is density function into d volume. So if I have x-axis and if I have fx, then fx is a velocity vector, then I want the net magnitude, the collection, then I have to do integration. I get the area or net collection. If I have a surface area fxy as velocity vector, and x-axis is nothing but on xy plane. If I do integration of it, then I get the area. Earlier I get the net collection, get the net area collection with the xy as independent component if I calculate the integration of the surface, that is fxy. Now if I have xyz as a cube plane, earlier we had a line, there we had xy plane as independent variable. Now independent variable is xyz cube, and dependent variable, that is a function, is function over xyz, that is density function. If I want to calculate, if I do the integration, then it would result in the density into the volume. Then it would result in the net kilogram. So that is fxy or pound, fxy z, f function over xyz, then d of the volume, and then volume one point to another point. If I break this volume in Cartesian coordinate, then it becomes dx, dy, dz. Now what is fxyz? Now it depends upon that. If it is really a function over xyz, then it's all right. If it is not like that and density is smooth everywhere, same, and that is 1. If I consider 1 or any constant k, consider 1 kilogram per meter cube, then this would result in the simple volume of the sphere of the cube. Okay, can we calculate the volume of the sphere with Cartesian coordinate the way we gave the fundamental, right? Okay, if that is the way, if that is the target, then what would be the volume of the sphere through Cartesian coordinate? So volume would be fxy dA and one position to another position. That is it. So if this is not available in any of the book. So if this is xy plane, so in the xy plane, I have a function fxy that results in a surface that is a sphere, that results in a surface, and that is a sphere. If that result in a surface and that is a sphere, if that is the case, then it is nothing but fx. Then what is the fxy? What is the equation of the sphere? X square plus y square plus z square equal to a square. So fxy, that is z, is a square minus x square minus y square square root. So what we are trying to calculate now? Square root of a square minus x square minus y square. Okay, and then dA is nothing but dxy plane. If that is xy plane, then it is dx dy. What is a square minus x square minus y square square root is? That is the hemisphere. If I keep give x and y as 0 0, that did result as full. Like if this is the sphere, then at origin, then height is full. But if this is a by 2, okay, this is a by, okay, radius is a. So if it is a, then what is the situation now? A 0, a comma 0, xy in xy plane a comma 0. Then what is fxy in a square minus x square minus y square square? That is 0. There is no fxy. So it is the equation. Now square root of a square minus x square minus y square dx dy, and now integration from minus a to a and again minus a to a gives the volume of the hemisphere. What is, if I calculate with the dx, then square root of a square minus x square minus y square. Okay, if I go with it, then what would be dx value considering y as constant? Okay, that someone has to calculate, or we can try or something like that. I don't know, a square minus y square. So if I keep x as a square root of a square minus y square sine theta. If x is square root of a square minus y square sine theta, then it would result in that square root of a square minus y square constant cos theta d theta. So dx is cos theta d theta, and this under square is a square minus y square minus and bracket a square minus y. I'm sorry, it is becoming 0 in this fashion. This is what I believe so. So something more intelligence is required, I believe so. So I have to keep y value or whatever. But this is the situation that is there. So square root of, if someone is very powerful, I believe it can be considered as questionnaire, that if I want to calculate the a sphere volume through Cartesian coordinate, that is fxy dxy plane. If fxy is the square root of a square minus y square minus x square dx dy. If I am doing integration through dx, then y is constant here. A square minus y square full, it is constant. If it is constant, okay, one sec. We tried in better way. I believe it was not way wrong. So if a square root of a square minus y square sine cos theta, consider cos theta equal to x, then a square root of a square minus y square minus sine theta is d. theta d theta is dx. Now dx I can replace with a square root of a square minus y square, that is constant, minus sine theta d theta, and here inside that a square minus y square minus x is replaced by a square minus y square cos square theta. So a square minus y square comes out and it is 1 minus cos square theta, that results in sine theta. So a square minus y square, and there again a square minus y square root would result in a square minus y square, that I can keep outside. Now it is sine theta, and again there is one sine theta. So sine square theta d theta, sine square theta d theta. So someone has to calculate integration of sine square theta d theta. I don't see that it is something that is very difficult. If I take, I don't know what is integration of sine square theta d theta. If I take chain rule, then sine theta, cos theta, again cos theta, and sine theta, something like that. Then again something would come, I don't know. Now someone has to keep the theta from minus, if it is we are taking full, then 0 to 2 pi, minus a to a is nothing but 0 to 2 pi, I believe so. So then it will become some constant. Leave the constant. Now it is integration of a square minus y square, a square minus y square dy, a square minus y square dy. That integration would result in minus y to the power 3 by 3. Okay, a square y minus y to the power 3 by 3. Okay, a square y minus y to the power 3 by 3. If that is the case, then y I have to set from minus a to a. That would result in a square y minus y to the power 3 by 3. Just set it, minus a to a and a to a. Net will become the volume of the hemisphere. This is through Cartesian coordinate, and it is achievable. It can be achieved. Cartesian coordinate and volume of the through the Cartesian coordinate. Okay, we have done enough for the Cartesian coordinate calculating the volume. This is our approach. Now let's move to the calculating the volume of a sphere through volume of a sphere through the kind of through cylindrical coordinate. Okay, so volume of the sphere through cylindrical coordinate. Let's go with the traditional way of generally you find in a book. Traditional way of calculating the volume. So what is the calculation of the volume through traditional way? We take a small, we take a small, if I, what is cylinder? What is a cylinder? This is cylinder. Okay, this is a circle, this is a circle, this is a circle, and on top of it I make a kind of perpendicular, then it is a cylinder. This is cylinder. Okay, this is cylinder in a way that its bottom is circular, and then there is a height. This is cylinder. If this is cylinder, okay, so if this is cylinder, then what is the volume of this cylinder? If this is cylinder, then what is the volume? If I take any finitesimal small section inside the cylinder, then what is the volume? Volume is nothing but surface area into the height. If I take a small cylinder inside that, what is the surface area of the, and then the height? So surface area in that is in polar coordinate. So we have seen enough for the polar coordinate. So surface area is r d theta dr, arc into radius. Okay, so r d theta dr, r d theta dr. If it is r d theta dr, then r d theta, what is the area of this circle? Area of circle is any strip if I take, then arc into radius. That forms a small strip as far as area is concerned. What is the perimeter of this circle? Then I'll take a small strip, that is the arc. Fuller. If I want area of the circle, then I'll take a small strip. Small strip means area y. So that is arc into radius. Radius into arc is a small strip. So now the arc is r d theta and radius is dr. Then r d theta dr is the patch, is the area, okay, into height. If height is dz, then the volume is r d theta dr dz. Now this I have to do bigger for the limit. So r is 0 to a, that is the full radius of the of the cylinder, and then 0 to a, an angle is 2 pi, and 0 to z is the height. Now, can you see we are calculating the volume of a cylinder, not a sphere. We want volume of a sphere. If we want volume of a sphere, then cylinder, the radius is not constant. For cylinder, whatever radius we are taking, radius is constant along the height. But a sphere, the difference between a sphere and cylinder, that radius is decreasing slowly. Okay, this angle is 2 pi and height is z, but radius slowly it is going less, and at the peak radius is 0. This proves that radius itself is a function over height. Okay, at any moment, if the height is z, then what is the radius? If any moment height is z, then what is the radius at that moment? How radius and height are interrelated? That is the question. So at any moment, if I say r d theta, dr dz, if I calculate dr first, then r starts from 0, but it does not end in constant a. Okay, it ends in function of z, that is the height, because r is everywhere, at every height r is different. This is something that is much more than marvelous. Okay, then consider, then what would be the function of, in terms of radius and height, in terms of height and radius? That comes as a question. What is at any moment, what is the r? At any moment, what is the r? Now consider a hypothetical sphere whose radius is a. Whatever the radius we are thinking of the sphere, there is a hypothetical sphere and radius is a. Anyway, we are giving 0 to a as constant to increase, that is the radius of the sphere one. But we are taking cylindrical coordinate. If that is the case, that at any moment inside the sphere, at any point, if this is the a and this is z, then what is r? R square plus z square equal to a square. Mind it. If I have a sphere, and a sphere is centered at the origin, okay, now if I take any point P, then there is a line that is the radius, that is a. If at that point the height is z, then whatever radius of that cross section we are seeing, that is the small r, that is variable. So small r equal to z square equal to hypotenuse. If that is the case, then r equal to a square minus z square square root. Now we have, now integration is dr r d theta dr dz. Now dr r d theta, now it is r dr d theta dz. Now this integration is from 0 to a square root of a square minus z square. r dr changes to r square by 2. R square by 2, if I set r square, then it will become a square minus z square and then by 2, whatever it is. D theta dr. D theta, if I integrate, it becomes 2 pi. Okay, then 2 to cancel, pi I can keep outside. Now it is r square minus z square is the integration. Now if I do with dz, then integration is r square z minus z cube by 3. Now if I set z, now 0 to a, 0 to a, that is the z. So r square, then it is uh, okay. So earlier it was z square, I believe, a square minus z square. So a square z minus z to the power 3 by 3. A square z, z is a. So a to the power q, a to the power q minus a z 3 by 3. So a to the power 3 by 3. That would result in 2a square by 3. 2a, 2a to the power 3 by 3. So that is the volume, 2 pi a to the power 3 by 3. I don't know it is correct or not, but that is the volume of a hemisphere. If it is volume of hemisphere, then volume of a sphere would be into 2. So 4 pi a to the power 3 by 3. Okay, so this is something that is not discoverable, but part of it has already been done. You can see the net. So I made a kind of, but approach is different. Approach is that now this the way we can think like calculating the volume of a sphere through cylindrical coordinate system. This is again interoperability. So if I have cylindrical coordinate system and if I take a small volume inside that, where the volume is dv, the one way of calculating the volume is calculate the dv and then dv 3 integration you make it. Another way that we will see, that is you have to calculate the fxy or function over the independent component along x axis, y axis, xy plane, or here it is r theta plane, and that function fxy d area, that if you do, then it will give you the volume. But we are going traditional way, dv triple integration. So v is, it is r d theta dr dz, where r is from 0 to a square, square root of a square minus z square, that resulted in r square by 2. That resulted in, now if we see, then a square minus z square by 2. D theta, if I integrate, then it is theta, then full theta is 0 to 2 pi. So 2 pi, 2 to cancel, pi came out. Now I have to integrate a square minus z square. If that is the case, then dz would be a square z minus z to the power 3 by 3. Setting from 0 to a would result in a to the power 3 minus a to the power 3 by 3, that is 2a to the power 3 by 3. If that is the case, then the volume of a hemisphere, okay, because half we are taking, okay, radius is half, means 0 to a we have taken the height, means half we are taking, because sphere is 0 to a and down 0 to minus. So it becomes 2 pi a to the power 3 by 3. Somehow we calculated through cylindrical coordinate system. I believe someone can proceed. Now, if I go through the spherical way, that is the default way. I believe we will see it. So we will try to calculate through the typical integration way. This is the way that will not give you long way, d volume and then calculating integration. If you go with a fxy dx dy, that will give you longer. Anyway, we have calculated the kind of volume of a sphere through cylindrical coordinate system. Actually, I had never thought that it can be possible. Somehow I tried now, and it is really looks like possible. So we will proceed in calculating the volume. Idea is person has to be thorough through both way. Through the traditional calculus way, fx dx gives the area, or d area integration also gives the area. Just d area, dA, integrate it, double integration gives the area, or fx dx single integration also gives you the area. Okay, fxy d area gives you the volume, or d volume gives you the volume, whatever you want. So both way we are trying everything. So we will proceed on it. So that is the concept.